Hello, myself Dr. D.K.Shedge, Professor in Electronics and Telecommunication Department, AISSMS Institute of Information Technology, Pune. Today we'll discuss flash type ADC, one of the analog to digital converter, flash type analog to digital converter. The flash type ADC is based on the principle of comparing the analog input voltage with a set of reference voltage. The set of reference voltage will be done with the help of this comparison will be done with the help of comparators. Typically, if it is an n bit ADC, n number of digital bits ADC, then we'll require 2 raised to n minus 1 number of comparators. The simplest example can be seen for a comparator for a 2 bit ADC. 2-bit ADC will require 3 number of comparators 2 raised to 2 minus 1, 2 raised to n minus 1, 2 raised to 2 minus 1. That is 3 number of comparators will be required. And the analog input conditions here, the levels, one of the input of comparator will be fixed. The first comparator, its input will be fixed at V by 4. Second comparator, its input will be fixed at twice V by 4. Third comparator, its input will be fixed at 3 V by 4. So the outputs of comparators accordingly, whenever the input is between 0 to V by 4, all the 3 comparators, their output will be 0. Whenever input crosses V by 4, the first comparator whose input is one of the input is V by 4, its output will go high. And whenever the input will cross 2V by 4, at that time the 2 comparators, their output will go high. And whenever input will cross 3V by 4, at that time all the 3 comparators output will go high. Only thing, now it will be needed to encode the output of comparators into the digital output. So coding circuit is designed for converting the output of comparator, which is also called as a thermometer code, to binary output. As it is a 2-bit, that's why very easily we can find out the encoding circuit, the digital circuit. So B1 and B0, accordingly we can assign the values 0, 0, 0, 1, 1, 0 and 1, 1. So whenever your input is from 0 to V by 4, the digital equivalent number output is 0, 0. Whenever it is greater than V by 4 but less than twice V by 4, it is a 0, 1. Whenever it is greater than twice V by 4 but less than 3 V by 4, at that time it is a 1, 0. And whenever it is greater than 3 V by 4 but less than V, at that time the digital equivalent number output is a 1, 1. So we can find out very easily what is the code for the LSB B1 and MSB B0. LSB B0 and the MSB B1. So B1, first of all, we can write as it is high for only 2 conditions of the comparator outputs, 110 and 111. That's why the B1 will be written as a C1, C2, C3 bar. Very easily you can get this combination, plus C1, C2, C3. So we can take C1, C2 common into bracket C3 bar plus C3, but C3 bar plus C3 will be equal to logic 1. That's why B1 expression will get as a C1, C2. Similarly, we can write for B0, which is now LSB B0. So B0 is 1 for combination 100. That's why we can write C1, C2 bar, C3 bar. And another combination is the 111, that's why C1, C2, C3. So same thing can be written as C1, C2 into bracket, C1 into bracket, C2 bar, C3 bar plus C2, C3, which we can recognize very easily that it is nothing but the XNOR gate. So C1 ANDed with C2 XNORed with C3 will be expression for B0, and expression for B1 will be only ANDing of C1 and C2. So same circuit very easily can be drawn. So as it is a 2-bit flash type ADC, that's why we'll require a 3 number of comparators. Actually 4 potential levels will be there, 1 by 4 V, 2 by 4 V, where V is the reference voltage, 3 by 4 V and V. So whenever your input will be greater than 1 by 4, at that time the lower comparator its output will go high. Whenever your input is greater than 2 by 4 of reference voltage, at that time both C1 and C2 will go high, and whenever your input is greater than 3V by 4, at that time C1, C2, C3 all three will be high, and then which will be followed by our logic circuit. Just now we derived the logic circuit, so B1 is getting to be C1 ANDed with C2, and B0 we are getting with a C1 ANDed with C2 C3 X naught together. The working of circuit will be very simple. There is only one attenuator which is formed with therefore 4 number of identical resistors of value R. While choosing R, we have to keep in mind that R values are much lower than the input resistance of comparators. Higher but much lower than the input resistance of comparator. So 4 identical resistors are chosen, and we'll neglect at that time the current drawn by input terminals of comparators. So 4 resistors will be in series, and using potential divider formula we can find out potential at these points. This will be 1 by 4V, this will be 2 by 4V, this will be 3 by 4V. Very easily we can find out this, and then same analog voltage is applied at non-inverting input terminal of all the 3 comparators. So whenever your analog voltage will cross 1 by 4V, at that time C1 will go high. Whenever your analog voltage will cross 2 by 4V, at that time the lower 2 comparators their output will go high, and whenever your input voltage will be greater than 3 by 4V, at that time output of all the 3 comparators will go high. The working of circuit is very simple, of a 2-bit flash type ADC. This is the working explained, but we can see also the working of this logic circuit. I think need not to go through B1 how will get when B1 will be 0 and when B1 will be 1, when B0 will be 1 and when B0 will be 0. That we can understand very easily. Similarly, we can build a 3-bit flash ADC. For 3-bit flash ADC will require 2 raised to 3 minus 1, that is 8 minus 1, that is a 7 number of comparators. So 7 number of comparators will require, and at the same time will require the attenuator of 8 number of resistors. These 8 number of resistors will be there. One resistor will be here before VR, and 8 number of resistors will be there. The lower comparator will have its input to be VR by 8. The second lower comparator will have its input to be 2 VR by 8. Third lower comparator will have 3 VR by 8, 4 VR by 8, 5 VR by 8, 6 VR by 8, 7 VR by 8 will be the fixed input given to the last comparator. And then we have to design now 3-bit priority encoder. Like we have designed there 2-bit priority encoder, we have to design 3-bit priority encoder here. Advantages of this flash type of ADC, because flash type of ADC is faster because input is reaching at a time to all the 3 comparators. That's why at a time comparison is taking place. That's why conversion time is much lower of flash type of ADC. It is 100 nanosecond or less the conversion time of the flash type of ADC. The construction is simple and very easy to design. Only we have to pay attention towards values of registers. Disadvantage, it is not suitable for higher number of bits because higher number of bits will require higher number of comparators. Will require 2 raised to n minus 1 number of comparators will be requiring. That's why the circuit will become complicated. With this only disadvantage, but it is the fastest one. That is the major advantage of flash type of ADC. Thank you.